Hello everyone. Hope you're having a great and amazing day. Welcome to Bright Beginnings. Our topic will be algorithms, sequence selection, and iterations. Okay, so first of all, we need to know what is algorithm. So algorithm is a set of instructions or rules that we create to carry out a task. This means that if you're trying to find a solution for something, you will try to step by step create some more answers to that solution. So this process is called algorithm, the solution, the process. Okay, so tools for designing algorithms. What are the tools to design algorithms? Okay, sequence, selection, and iteration. We need to know these three important. Sequencing is the order of the instructions in an algorithm. So it's like a step-by-step order. Step 1, what do you have to do? Step 2, step 3. It's not like step 3 going in the beginning, then step 2 in the middle. So you need to organize your this algorithm. So sequencing will come in handy at that time. Next is selection. So this happens when you reach a step in algorithm where there are two or more possibilities. This means that there are two options for you, and you have to use your brain to think which one is the better option. This is called selection, in which you choose the choice. This is what you should know in selection, choosing the better option. So iteration is repetition of a step or task in an algorithm using the help of loops, programming loops. So this means that you're repeating a task again and again for some use. Okay, so we can see three pictures here on sequence, selection, and iteration. So I said it that step by step, it's going in an order. Selection is like there are many people here, so you're choosing between them, as I said, choosing between two or more possibilities. Iteration is just a loop to show how the loop is going. Okay, now write algorithms to make a cup of coffee. Add two numbers. Find the largest of two numbers. Print hello world 10 times. Now, algorithms to make a cup of tea. So as I said, algorithm can be anything in real life or in programming. You can use it at any time, anywhere. Okay, so now we have a question here to make a cup of tea. This is a real life demonstration here. Step 1. First of all, take an empty vessel. Step 2. Add a cup of water to the vessel. Step 3. Place the vessel on stove. Step 4. Add sugar to the water. Step 5. When water starts boiling, add tea leaves to water. Tea leaves to water. Allow the water to boil for 5 minutes. This is step 6. And now step 7 will be now add a cup of milk to the mixture. Step 8. Remove from flame. Step 9. And your cup of hot tea is ready. Now, I'm going to explain you how there's sequencing is happening here. See, do you think that you can bring step 7 instead of step 2? Yes, you can, because even water and milk is fine. But if you're going in an order, if you go for step 5 and step 2, so you're like, first of all, take an empty vessel, and then step 5, you're like, when the water starts boiling. That does not make sense. That's why sequencing is here. Sequence organizes that part you're using. Okay, now we have an algorithm to add two numbers. This is for programming. Okay, so we have a step 1, start. Step 2, input the first number, A, meaning that the user is going to type the first number. Step 3, input the second number. He's going to write the second number, which is stored in variable B. A and B. So now you're going to find the sum. Step 4, sum is equal to A plus B. This means that the calculation is happening here. The data stored in the variable A and the data stored in the variable B. We will need to find the sum. Once that's done, step 5 occurs. Display the sum. Step 6, stop. After displaying, now it's done. The user has got his answer. Now the program is going to stop. algorithm to find the two largest of two numbers. Step 1, start. Start. Input A and B, two values. Its comparison is happening here. Step 3, if A greater than B, then output A, else output B. Stop. This means that when you start the program, you have to type two numbers, the one you want to compare from each other. For example, 6 and 7. So now, if 6 is greater than B, then output A. So if that number is greater than the other number, that will be the output. If it's not, else the next number will be the output. At the last, when the user gets his information, he has to stop. Okay, now how are we going to print algorithm hello world 10 times? Now, if you want to do that, step 1 will be start. Step 2 will be count is equal to 0. So our counter has the value 0. There is no value yet. Now, print hello world. That's the word, the value which we want to print. But it's going to print in one time only. Step 4 will be count. The variable count is equal to count plus 1. Meaning that every time a hello world is printed, then count value will be added. Step 5, if count is greater than 10, now the count keeping on print hello world is printing. Now the value has reached its maximum data, so meaning it's on 10 now. That's why we use the if here. So once the data reaches 10, go to step 3. Do it again and until it prints 10 times. Step 6 will be stop. You're done. It has done 10 times and now the program is going to stop. It's quiz time now. Okay. This type of algorithm is represented by the if or then problems. If a condition is true, the output will be A. If the condition is false, the output will be B. This algorithm type is also known as selection. So the scientific word of this is branching. Okay, what is an algorithm? The question. Okay, an algorithm, is it focusing on the important part? Is it sequence of instructions or how to solve a problem, breaking down a problem into smaller parts, the recipe for a cake? Oh, come on, what is this? It's gonna be a sequence of instructions. Why is selection important? Why do you think selection is important? Because they make us more, because it allows us to include more than one path through a solution. We have many choices here. Instructions carried out one after another in order is series, list, collection, sequence. I said carried out one after another in an order. Sequence is always related to order. It's this one. Okay. When can algorithms be used? Only with computers? Flowcharts? Programming? Anytime? What do you think? I think it's anytime. As I said, in reality and in programming, the cup of tea or computer. For this type of algorithm, the process might be executed under a certain condition. So of this type, the process might be repeatedly executed, repeating. The word repeated means iteration, every time a loop repeats. Which is the definition of sequence? When instructions repeat, a set of instructions specific order code where decisions are made. This one is this one. Okay. What is the definition of iteration? Repetition. Code where decisions are made, set of instructions, or where instructions repeat. As I said, wherever you see repeat, all know it's iteration. Why is iteration important? Why do you think it's important? I think so. It removes duplicated steps. I'll quite explain you that question. Here, it allows code to be simplified by removing duplicated steps. So that's why it keeps on moving and moving to checking if there is anything extra which we do not need. Duplicated examples, that's what it removes. While the program is running, if the program makes a choice, if it should run some code or not, it's called a choosing, selection. Okay guys, so we are done for today. Please subscribe to this channel. Love it for having your support. Bye bye.